Welcome back, everybody. What we're going to talk about today is mostly a review from physical science. You might remember some of it, you might not remember some of it. That's okay, we're going to go over it together. If you haven't taken physical science, you may have learned some of it in middle school, but either way I think you'll be able to pick it up okay. We'll be talking about the general structure of an atom, and specifically today, the electrons of that atom, the negative particles. Now an atom has three main particles that make up the atom, three parts. We've got the proton, which is positive, and the neutron, which is neutral. It's got no charge. The proton and the neutron both are found in the nucleus. The nucleus is just the middle of the atom. I know that cells have a nucleus too, and you may remember that from biology. But there's no connection between that nucleus and this nucleus, except for the fact that they're both in the middle. What we're going to focus on today is the electron. It's got a negative charge instead of positive. It's got a -1 charge. And it's not found in the nucleus. It's found outside the nucleus, in an area we call the electron cloud. There's a broad area, much bigger than the nucleus itself, where electrons orbit the nucleus. They go around and around. Not actually in a circle, but the circle is the easiest way to draw it for our diagram here. Now there are some relationships between these particles, protons, neutrons, and electrons. An atom will always have as many electrons as protons if it's neutral. And by neutral, I mean it has no specific plus or minus charge. It's just a charge of 0. At first, all of the atoms we deal with are going to be considered neutral. So number of protons, which is pluses, has to be canceled out by number of electrons, which is minuses. Electrons usually have close to as many neutrons as protons, but it's not nearly as hard and fast of a rule, and later on you're going to get some weird numbers. But that's not important for today. We don't care about that. As an example, hydrogen has 1 proton and 1 electron, proton, electron, same number. Helium has 2 protons and 2 electrons. Carbon, although you can't see them all in this little computer-generated picture here, has 6 protons and then 6 different electrons. That means we got 6 plus charges and 6 minus charges, giving us a total charge of 0, because it's neutral. Now we can tell a lot about the atom just from this same square on the periodic table that you've been looking at so far. Some of the things that we've talked about so far have been the symbol. You guys had to memorize some symbols. The name, that's pretty straightforward. And we've used the molar mass, the mass of 1 mole of those particles. That's how we go from grams to moles and back again. Well, what we're going to focus on today is this number. We call this the atomic number, and this tells us the number of protons and the number of electrons that we find in a neutral atom. So oxygen, 1 atom of oxygen has 8 protons, and because they're all neutral right now, it also has 8 electrons. Now I'm going to show you some pictures of the models. We're not going to focus on the models too much to begin with. But there's 2 different ways we're going to model the atoms, not just this trimester, but also for the next 2. There's the Bohr model. Oops, sorry about that. There's the Bohr model. And the Bohr model is going to be like what you saw back on the 3rd slide. We've got a bunch of circles in the middle, the nucleus, representing the protons and the neutrons. And then around that, organized in rings, we have some smaller circles representing the electrons that are orbiting. For now, I just want you to be able to recognize that. You'll see a picture of it on the next slide. And the next one is the Lewis dot structure. Lewis dot structure is a little more simplified, and I'll introduce that in just a moment. Here's an example of the Bohr model. It shows all the particles in the atom, the pluses, the minuses, and the negatives. We've got in the middle our 2 protons and our 2 neutrons. And then orbiting around it, we've got 2 electrons as well. So if we want to know what element this represents, we can go back to what we were saying earlier with the atomic number. The atomic number tells us the number of protons and neutrons in an atom. So, if the atomic number is 2, then that means that there are 2 protons. Or to look at it backwards, like we have here, there are 2 protons. There are 2 positive particles in the nucleus. Therefore, our atomic number is 2. Also, since it's neutral, it works for the electrons. There are 2 electrons, 2 negative particles zooming around the outside there. And so our atomic number must be 2. And if we look on the periodic table, we find element number 2, and that's helium. So this is a model of helium here. Now electrons have special rules. Unlike the protons and the neutrons, which are all just shoved into the nucleus, electrons have to have a specific structure. You can't just fit all of them into the same first orbit, the same area around the nucleus. If you did, they would repel each other because they have these negative charges. And so instead, electrons are found in energy levels, or shells, which are like layers in a gobstopper. If you start out with a gobstopper, you'll know, or if you ever had a gobstopper, you know that it's made of several different layers of different flavors. And each of those layers are separate from the others. The electrons are kind of the same way. If we have a center, a nucleus, in our atom, the electrons orbit it in different layers. And we call these layers energy levels. Here's another way of looking at it. You've got a nucleus in the middle, and then we have other shells, other energy levels outside it. And you can see as we go from inside to outside, they get bigger. And the bigger they are, the more electrons they can hold. So our first layer, first energy level, first shell, can hold a max of 2 electrons. It can hold less than that, sure, but no more than 2. The second layer can hold a max of 8. It can hold less than 8, but not more than 8. But the second layer will not get filled until the first layer is filled. So you fill the first layer, and then you move on to the second layer. Then you move on, if you've got the 2 and the 8 already taken care of, to the third layer, which can hold a max of 18. And so on and so on and so on. You've got to fill a layer before you go on to the next one. The key here is this statement. Like we said, you've got these different layers. You can only have so many atoms in a specific layer. But the most important layer for us is the outer layer, the layer on the outside. And the electrons in that layer are called the valence electrons. If we go back to our gobstopper analogy, if you have 2 gobstoppers and you click them together, the only part that touches is the outside layer. And an atom is the same way. The only part of the atom that touches the world around it is the outside layer, the valence electrons. And so they're the most important to us because they're the ones that affect the world around them. So let's take a look at this picture here, this square from the periodic table, and try it. So, if we want to draw a lithium atom, we look at the periodic table and find the number of protons. So we go to the atomic number, which is right here. That's the number of protons we're going to have. So we're going to have 3 protons, 3 positive charges, which I have helpfully drawn for you right up above there. Now we want to figure out how many neutrons there are. Now the atomic mass is this one right here. And number of neutrons is always atomic mass minus atomic number. So we take the number at the bottom and we subtract the number at the top. 7, which is our total mass, minus 3, which is our number of protons, gives us a number of neutrons of 4. there are 4 neutrons, because it's atomic mass minus atomic number. So we're going to draw our 4 neutrons. Kind of sloppy there, I know, but this program doesn't have the best way to zoom in and make things look prettier like Notability does. Yours should be prettier. You'll notice there's no plus or minus in there because neutrons are neutral. They don't have any charge. Finally, we look at the number of, here we go, here's where we're looking. Look at the number of electrons. And remember, since it's neutral, again, it's just the atomic number that we're looking for. This one right here. We have 3 protons, we also have 3 electrons. So we're going to draw 3 electrons zooming around the outside of the atom. Now here's the problem. We can't just draw 3 of them because 3 is too many to fit in the first layer. Go ahead and pause it now, flip back or rewind and look at the previous slide where we talk about number of layers and how many electrons fit in each layer. Maybe a few slides back. I'm sure you can find it. It's got a picture there. So now that you've looked at it, you probably see that the first layer can only hold 2. Well, we have 3. That's too many. So instead of trying to cram them all in, we do our first layer, which has 2 of the electrons. And then we've got 1 electron left over. So it overflows into the second layer. And there's a very ugly version of a Bohr model. Like I said, you'll have more room on Notability, so I think you'll be able to make it look a little bit prettier. Kind of like this. See, we've got our 3 protons in the middle, because the atomic number is 3. We've got our 4 neutrons, because 7 minus 3 is 4. And we have our 1, 2, 3 electrons, because the atomic number is 3, with 2 of them in the first level, and the 1 overflow in the second level. The Lewis dot structure is a simplified version of this. If we take a look at this diagram on the bottom, this is a Lewis dot structure for oxygen. While above it, we have the Bohr model for oxygen. Obviously, it's a lot simpler on the bottom, right? The reason it's simpler is it just shows the outside layer. See how there are 6 electrons on the outside, up on the top, the Bohr model? And down on the bottom, the Lewis structure also has 6 electrons. So, here's how you write a Lewis structure. First, you write the symbol. Let's do one for, let's say, carbon. So, symbol for carbon is C. Then, and we're going to start on the right-hand side for this, and we're going to go clockwise, and we're going to add in electrons. Each electron we add is going to be a dot, or we're going to do them one at a time. So carbon has 4 valence electrons. Remember, we're not talking about how many total electrons carbon has, which is 6, because it has the atomic number of 6. It has 4 valence electrons, because of those 6, 2 go in the first layer, and then 4 more, the next 4, overflow to the second layer. The second layer is outside it. So the second layer is the valence layer. So we got 4 electrons, so 4 dots. 1, 2, 3, 4. That's the Lewis structure for carbon. Now if we did something that had only 3 dots, like say boron, we would have a B, and then 1, 2, 3. But if we had something that had a few more dots, like 5 or 6 or 7 or 8, for instance, nitrogen, no, we can do that later. For instance, sulfur, well, that's not good either. Oxygen, there we go, let's do oxygen. Oxygen has 8 total electrons. Of those 8, 2 go on the first layer, so we have 6 more left over. So let's put those 6 electrons on. 1, 2, 3, 4. Now that I've gone all the way around, I start to double up. 5, 6. So I have a pair, and then a single and a single. And that's the Lewis structure for oxygen. Electrons can fit in pairs for reasons we'll talk about later. You can have a solo electron or a paired electron. You can never have 3 or 4 though, so that's a great way to double check yourself to make sure you haven't done anything wrong. To practice this, watch this again if you had trouble, make sure that you're listening to my explanation, and then try to draw lithium, nitrogen, and neon. Go ahead and pause right now, because in a moment I'm going to show the answers, and you want to test to see if you're doing it right. First, here comes the answer for lithium. There's our Lewis structure for lithium. Lithium has 3 electrons, 2 go to the first layer, so 1 is left over for the valence on the outside. Here comes nitrogen. Nitrogen has 5 valence electrons. It has 7 overall, 2 for the first layer, and then 5 left over. Now, neon. Neon has 8 valence electrons, 10 total, 2 for the first layer, 8 in the second layer, and so it's got 8 on the outside. And 8 is the most number of valence electrons that you're going to see. We call that an octet. If you had more electrons, if we move one further on from neon to sodium, I believe, Na. If it's not sodium, I'll look silly. But if we move on to something that has an atomic number of 11, so 11 electrons, 2 would go in the first layer. We'd have 9 more. Of that 9, 8 would fit in the second layer. Second layer fits 8. If you don't remember this, go back a couple slides and look at that slide where we talk about the layers. And then we'd have 1 more still, which would overflow to the third layer. Then the third layer would become valence, because valence is just a fancy way of saying outside.